Hi team, welcome to a walkthrough of the practice test for Unit 5. Woo! So here we go. These you want to determine the value of the following without using a calculator. These are just, we've been practicing a lot of Pythagorean Theorem. You might have to take the square root of 16, and you might happen to know that 4 times 4 is 16, so this is equal to 4. Okay, cool. Because yeah, that's what the meaning of square root is. This one is 9. We just memorized our squares. We know 9 squared equals 81. So if I ever have to take the square root of both sides, I would have 9 is equal to the square root of 81. Okay, and that's this here that I've written for your benefit. Now, this one is a bit of a challenge problem. We want to know what two numbers multiply together to give 90,000. 90,000. So how can you think your way to an answer here? Use a factor tree. Okay, thank you, random student. Wait, me, who did factor tree. Okay, so 9,000. That could be written as 9 times 10,000. Both of these happen to be perfect squares. 9 is 3 times 3. And in this one here, I can just count zeros. There's 4 zeros. So if I multiply 2 zeros with a 1 in front by 2 zeros with a 1 in front, I would get that. So 90,000 is equal to 3 times 100 squared. Because there's 1, 2 100s and 1, 2 3s. So it's equal to 300 squared. So this one is equal to 300. Okay. So you can use factor trees to take these apart, and there's tricks with the zeros. Because there's 4 zeros, it's going to be 200s multiplying each other. Ooh, let's keep going, everyone. So when we're estimating these without the help of a calculator, we want to know what squares they fall between. So 4 squared here happens to be 16. The square root of 23 squared is 23, and 5 squared is 25. So if I had to estimate the square root of 23, that'd be like, I don't know, 4.8, maybe? I'm not sure. Maybe it's 4.7, maybe it's 4.9, but somewhere in there, 4.8 or so. Okay. Square root of 50, well, I know that 7 squared is 49. And the square root of 50 squared is 50. So it's just like maybe 7.06 or something like that. And now, how about this one, the square root of 300? What are some squares that are close to 300? Well, I happen to know 17 and 18 straddle it. Okay, 17 squared is equal to 289. And 18 squared is, give me a second, 314, I believe. 18 squared. Looks good. Anyway, so no, I think it's 324. 324. Must be, yeah, 324. Okay, so yeah, so in that case, this is falling like pretty much right in between them. So I'd say like 17.45 or something. Okay, circle it, final answer. Circle it, final answer. I'm not going to verify with a calculator because I was instructed to not use a calculator. And my guess is pretty good. So there we go. Now, in this diagram here, what's being shown? Well, a squared plus b squared equals c squared. Okay? This one squared plus this one squared should equal the square of that one. And that's what we have there. Okay? This is a curious and very interesting fact, which I've been reflecting on quite a lot lately, and there's really some interesting relationships there, but that's neither here nor there. Okay, but it's actually not. It's not equal to 15 plus 17. It's equal to 15 plus 17 over 2. It's the average of 15 and 17. Very cool. Okay, this is simply not true, and this is just some weird thing that they wrote down. If I want to know the third length of this side here, this is what I do. I write down first the formula. Do this. It's good math habits. Start from rock solid facts. And then I can substitute in 30 squared plus 40 squared equals some number squared. And I call this one C. Give me one moment. Let's carry on. So then I've got this down. Then I do 30 squared, which is 900, plus 16 squared, which is 400 squared, which is 1600, equals c squared. Yeah, that's where you put your cheat sheet. Yeah. So 2500 equals c squared. It would be nice to have a little bit more space on this test, wouldn't it? And then I happen to know that 50 times 50 is 2,500. If you didn't know, you would take this line, 2500 equals c squared, and then you would take the square root of both sides, and that would give you 50 equals c. You can also answer this type of question by noticing that it's a Pythagorean triple based on the 3, 4, 5 triangle. Okay, so the 3, 4, 5 triangle, 3 squared plus 4 squared is 25, and so that's 5 squared. So this one, if I just multiply every side by 10, I get the same angles, I get the same shape. It's just bigger by factor 10. So this would be 50 instead of 5. This one, on the other hand, use the Pythagorean theorem to determine the length of the third side, and please show your work. That's very important. So start with a squared plus b squared equals c squared. C squared this is c. Remember, c is always the longest side. Otherwise, you may make a mistake. 3 squared plus b squared, 2 squared there. So we'll call this a, and this is b. Okay? And now 2 squared is 4, plus some number squared equals 9. Okay, subtract 4 from both sides. B squared equals 5. Take square root of both sides. B is equal to the square root of 5. And it didn't tell me to approximate, so I would just say it's square root of 5 centimeters long. Or if I want to tell you a decimal approximation, it would be 5, but I take the square root of it. 2.236, 2.24. Therefore, B equals 2.24 centimeters. Circle it as my final answer. Cool. Let's keep going. Determine the total shaded area of the shapes shown below. All right. So to determine this shaded area here, I'm going to say that the area that's shaded is equal to the area of the rectangle minus the area of the triangle. I'm going to put in my formulas. So this is equal to length times width minus 1/2 base times height. Okay, that's my formula for the area of a rectangle, my formula for the area of a triangle. All right, so let's do that. 18 times 15 is 120. 120, that's 8 times 15. Okay, this one times that one, minus 1/2 base times height. So 1/2 of 8 is 4. 4 times 4, this is area 16. This is area 120. So I have 120 minus 16. The area equals 104 centimeters squared. Don't forget to write the unit down there. That's important. Okay, now this one is the shape that cannot exist in our world. But don't worry, I've already sent an email. So here, we want to find this shaded area here. It's the area that's shaded is equal to the area of the trapezoid. That's the trapezoid. Plus the area of the semicircle. Okay, so if this is area trapezoid, this is area semicircle. Okay, I'm going to find the combined areas there. So let's do that. Okay, the area of a trapezoid is equal to A plus B, which is the top plus the bottom, divided by 2. The average of the top and the bottom multiplied by the height. So this is A, and this is B, and this is H. Okay, you can even write your letters on the diagram to avoid making mistakes. Plus the area of the semicircle, well, it's half of a circle, so I'm going to divide it by 2 pi times the radius squared. The radius happens to go from here to here, and that would be 6 according to their diagram. Okay, so let's keep going. All right, so A plus B times H. 12 plus 20 divided by 2 happens to be 16. 16 times the height is 160. Okay, just substituting in there. Let's evaluate this. Plus pi times the radius squared times 2. The radius squared is 36. 36 divided by 2 is 18. So that's 18 times pi. Notice I'm skipping steps now that I don't have a lot of space. I'll give you more space on your test. It'll be a 4-pager instead of a 2-pager. You'll have lots of space. So 160 plus 18 pi is an exact value. Let's determine what the rounded value is. 18 times pi plus what, 160? Well, yeah. Plus 160 equals 216.5 equals 216.5 centimeters squared. Cool. Okay, let's consider these two containers and find their volumes. Volume of a rectangular prism is equal to length times width times height. So in this case, that's equal to the length, which is, we'll call it 10, times the width, which we'll call 6, times the height, which we'll call 3. Okay? 10 times 6 times 3 is 180. 180 centimeters cubed. Because we're counting cubic, we're counting sugar cubes there to say how many cubic centimeters that is. And then let's do the volume of this one. This one is going to be the volume is equal to the area of the face, which is pi r squared, multiplied by the length. We don't know r because that gave us diameter. R is 1.5. Okay, so let's put that in. The volume is going to be equal to pi times 1.5 squared times 10. I was almost going to do an L. Okay, 1.5 squared happens to be 2.25. 2.25 times 10 is 22.5, so the volume is 22.5 times pi. Now go to your calculator and do that with the pi button. Clear. 22.5 times pi equals 70.7. Okay? Equals 70.7 centimeters cubed. All right. Now, we want to determine the surface area of these two containers above. Now, if we're going to determine the surface area, you can just plug and chug the formula that's on your formula sheet, but that bores me. Think about this as like we have this side here, side number, change the color. Mr. Jennings, we'll go with red, will show up very nicely. Okay, this surface area is surface number 1, this surface is number 2, this surface is number 3. Number 1 happens over there, and there's a number 1 hiding there. There's a number 2 hiding behind that prism, and there's a number 3 hiding underneath under there. Okay, so there's 2 of the number 3 surface, because it's the same surface on top and bottom. There's the same surfaces on the sides, and there's the same surfaces there. So we want to add all those up together. Let's do that. All right, surface number 1 is 6 by 3. So that has area 18. So we would have 18 times 2, because there's 2 surface number 1s. And then this surface here is 10 by 3. So that's 30 times 2. And then this surface here, 3, is 10 by 6. So that's plus 60 times 2. And the reason why I'm multiplying each one of these by 2 is because I have 2 of each one of those surfaces. There's 6 surfaces in total. This is 2 of them. This is 2 of them. This is 2 of them for a total 6 surfaces. And let's do our bedmas. 18 times 2 is 36. 30 times 2 is 60. 60 times 2 is 120. And that gives me 216, I believe. That's 180 plus that's 216. 216 centimeters squared, because I'm measuring area. Okay. And now, let's do the area of the green container, again using a thinking method rather than the formula that's on your sheet. First step would be to draw a net. Okay. So here is the net that I will draw. It's going to have a thing there with a diameter 3. And then there's going to be a rectangle if I unroll that cylinder. And then there's another circle somewhere along that there with diameter, same, 3. Okay? That's if I cut this down the length and then cut it around here and then unroll it. I have to cut it around the other side too. Okay? And then I unroll it, and I would have 3 separate areas that I add together for the total surface area. Okay? The areas of the circle is pretty easy. There's 2 of them, so the total area is going to be equal to 2 multiplied by the area of the circles plus the area of the rectangle. Okay? The rectangle's length is given as 10, but what's this one here? Well, if I imagine rolling this into a cylinder, see there's a circle on the end, right? And this length here along this edge of paper would be equal to the circumference of that circle. You see a circle there? See the circumference? When I unroll it, it's still the same length. That's now the circumference of this circle. So that would be, well, how do I find the circumference given diameter? Circumference is the relationship between diameter and pi. Pi times diameter equals circumference. So this is 3 pi long here, and this is 3 pi as well. 3 pi long. Not pylons, 3 pi long. All right, so the area is equal to 2 times the area of the triangle, because it's the area of the circles, because there's 2 circles. So that's 2 pi 1.5 squared, because use radius, don't use diameter and make that mistake. And then plus area of the rectangle, which will be 10 times 3 pi. Okay? So now we've got the area is equal to 2 pi times 1.5 squared. 1.5 squared is 2.25. 2.25 times 2 is 4.5. So this is 4.5 pi plus 10 times 3 times pi plus 30 pi. So the area, total area, is 34.5 pi. 34.5 pi. $108.4. So this is equal to 108.4 centimeters squared. Done. Final answer. This last one, an ice cream cone. This really demands that you draw a diagram, okay? So I'll draw you a nice diagram here after I zoom in and make this a little smaller. I get my ice cream cone color, which will be that. I make this super thin. Hold on one moment. Okay, carrying on. So here's our ice cream cone. It sits like that, and it's this way here. So this has a radius. I'm just going to draw that in there because I'm going to draw that of 5 centimeters. And it is from here internally 15 centimeters tall. Okay, hold on. There's a typo that we're discussing here. Okay, carrying on. And then we have a semicircular ice cream ball, and we'll use purple for our ice cream. It's cotton candy ice cream, maybe. And it comes up here like this, and it's a perfect sphere of radius 5 centimeters. Okay? And so we want to know if they fill it entirely with ice cream, this should be centimeters cubed, not centimeters squared. There's a typo there that we were just discussing. Okay, then we're going to say that the volume of the total ice cream that's needed to fill the cone all the way to the bottom and also fill like a semicircular scoop on top is going to be equal to the volume of half of a sphere plus the volume of the cone. Okay, so let's put in our formulas. This would be 4 over 3 pi times the radius cubed, but divided by 2, because I only have half of the circle sticking up, plus the volume of the cone, which is pi times the radius squared times the height, all divided by 3 is the formula for volume of a cone. All right? So now let's do that. This will be equal to, the half of 4/3 is 2/3. Okay. Pi times the radius cubed. Well, the radius is here 5. 5 cubed is 125 times pi. Okay, that's the volume of that ice cream, plus pi times the radius squared, which is 25, times 15. But 15 divided by 3 is 15 divided by 3. Sorry, I'm a little distracted. 15 divided by 3 is 5. So the height divided by 3 is 5 times 5 squared would be 125. So this is plus 125 pi. Okay. So this is all together 5/3 times 125 pi. And then that's equal to, what is it? Let's just crunch it on a calculator at this point. So to do that, we would do 2 divided by 3 equals, that's 2/3, multiplied by 125 equals that, times pi equals, that's the volume of the 261.8 centimeters squared. Okay. And then we go back here to the calculator. And then I want to find 125 times pi. 125 times pi equals 392.7. Add these together, and that will give you 261.8. 654.5. So it's about 0.6 of a liter. 0.6 of a liter of ice cream is going into this ice cream cone that's altogether 20 centimeters tall and 10 centimeters across at the top. It's about it's a little bit less than 2/3 of a liter. Okay, because a liter would be 1,000 milliliters of ice cream. Okay, so this sentence, this question needs a therefore statement. Therefore, we need 655 milliliters of ice cream per cone. So we can make about we can make sorry. We can make about 3 ice cream cones for every 2 liters of ice cream. Okay. There we go. So that's your measurement test walkthrough. I hope your math practice will be fruitful today. Any questions, absolutely hit me up by email. Bye.